All right, sounds good. Okay, so welcome. Really glad to have you all here with us today. I'm Bianca Moebius-Clune, National Director of Climate and Soil Health here at American Farmland Trust. Before I get us started, I want to acknowledge our partners. We have US Biochar Initiative and USDA's Agricultural Research Service with us today. They are working with us on this webinar series and on the project that funds it. I also want to acknowledge our funding from USDA NRCS that's making this work possible. Thank you so much to USDA for providing this funding. Today, we get to hear about a number of examples of on-site biochar production at several scales, from the small pit in the ground that can be implemented by anyone who has time but not money, to on-site production services, such as using an air curtain burner. So I think that's really exciting. We hope you find today's topic as fascinating as we do. We've gotten a lot of questions about the space of, can I make it myself? How would I do that? What's available? So we're going to get started in that. We hope that you tell us what biochar questions you're grappling with, whether that's in this space of on-farm production, on-site production, or whether you have other questions. We can answer some questions here today. We're happy to design new webinars in the future that tackle the topics that you bring up that you want to hear about. Next slide. Few brief logistic notes. We are recording this webinar today, and we are adding that recording to our toolkit. We have live transcript enabled so you can engage with us. We hope that you put your questions in the Q&A at any time. Myles from USBI will facilitate the conversation after both speakers share the insights with us, as I actually will need to step out. So I'm here to say hello today, and then I will step out about 45 minutes in. I want to call out our evaluation survey. We very much hope that you take the time to fill it out. We really want to hear from you. We take your input seriously. We would love your questions, your suggestions for improvement, any topics that you would like us to address in future webinars. So please do let us know. Next slide. I want to take a moment to introduce American Farmland Trust. We are a nationally connected nonprofit organization that takes holistic approaches to agriculture. We work at the interface of the land, the farmers, the ranchers who manage that land, and the agricultural practices and systems of practices that they use on that land. So since our founding in 1980, AFT helped launch land trusts and other farmland protection programs, permanently protecting about 8 million acres of agricultural lands across the country. We've also advanced soil health and other practices across millions of acres and supported tens of thousands of farm families, and that is growing quickly. We do our work literally from kitchen tables to the halls of Congress. So we systematically combine our work on the ground, our coalition building, our policy work, and our research and technical guidance development so that we can holistically make an impact for agriculture. We're working across partners and stakeholders, not just to bring about change in small pockets of agriculture, but we're actually really looking to catalyze a transition to a new conventional agriculture, a new normal that we can all be proud of, where farms and ranches truly thrive across the country, where their production systems are resilient, soil health promoting, diverse, economically viable, equitable, climate neutral or better, and sustainable. So that's really ambitious. It will truly take everyone working together to accomplish that, and that's a small piece of that is what we're here for today. We really hope that you engage with all of us and that you help us make impact in this space. As we do all of our work, we are really working across systems. And so we see biochar as a core tool in a soil health management toolbox that's ready to scale up and to be fully integrated into agriculture across the country. We've launched a number of large-scale projects that are going to scale up biochar use on farms across the country. We'll connect biochar producers with users of biochar, we'll provide technical guidance, and we'll help folks understand and address barriers to that integration. This webinar is a piece of that body of work. Next slide. You will find the full practical biochar implementation webinar series on AFT's Farmland Information Center site. That's our virtual library that we host. We will post this one there shortly, and we have more webinars coming, so definitely look out for updates. I am here today with my AFT colleagues, co-host Aisha Tapp-Ross, soil health and microbial scientist who has led all the behind-the-scenes work to organize this webinar series, and also co-host and one of today's speakers, Dr. Kiros Hadgu, senior soil health and biochar scientist. We also have with us today Myles from US Biochar Initiative and Kristin Trippe from USDA ARS, both of whom we will briefly introduce their work before I introduce today's speakers. So I will pass to Kristin, microbiologist at USDA. She serves as PI on the National Biochar Atlas project that's funding this series, and she will then pass to Myles Gray, executive director at USBI, and then back to me for just a brief moment. So go ahead, Kristin.
Thanks, Bianca. As Bianca said, I'm Kristin. I'm a researcher at the USDA located in Corvallis, Oregon, and I'm really interested in understanding products and practices that can improve soil health on degraded landscapes. And as part of that, we've put together a expansion of our local Pacific Northwest Biochar Atlas tool so that it's relevant to the entire United States, and so that it actually includes biochar that you can purchase from a local distributor. So as part of that, we're working with a lot of partners to develop the National Biochar Atlas, to get biochar from different producers, characterize that biochar, and use it to kind of provide a database of biochars that can help farmers find a biochar that addresses local concerns that for their soils and their crops. As part of that, we're expanding the map and the crop functions of the Biochar Atlas, and we're doing a lot of outreach in collaboration with USBI and AFT to help farmers and conservation planners understand how the National Atlas works. The National Atlas has now, a very beta version of the National Atlas is now available on the Pacific Northwest Biochar Atlas website, and you can find that at pnwbiochar.org. And with that, I will pass it to Myles.
Great. Well, thank you, Bianca and Kristin and the rest of the AFT team. Just a quick introduction for a U.S. Biochar Initiative. We're a 501c3 focused on increasing production and use of biochar in North America. The main way we do that is by focusing on increasing demand for physical biochar in agricultural, industrial, environmental, and built environment markets. And clearly this type of webinar series feeds right into that approach. Everything we've seen is that building out the biochar industry in the United States really requires us to build out demand for the physical product, particularly among farmers and others related to agriculture. The other big thing we do is we host an annual conference, which is the largest biochar conference in North America. Our next conference is coming up here in September in Minneapolis, September 15th to 18th. We're really excited about it, and you can find more information at biocharconference.com if you're interested in coming. We would love to have you. So with that, I will turn it back over to the AFT team.
Thank you, Myles, and thank you, Kristin. It's so great working with you. This has been a really fun collaboration. All right, so let's dive in. We are talking about small-scale biochar on site at several scales today. Dr. Kiros Hadgu will start us off with very small-scale do-it-yourself approaches. Kiros joined AFT this January, so just fairly recent, as our senior soil health and biochar scientist. Kiros comes to us from Ethiopia, where he held senior positions in C4 ICRAF, leading programs in soil health, agroforestry, and landscape scale restoration efforts, including through biochar, across Eastern and Southern Africa. He brings 12 years of experience integrating work across science, on-the-ground adoption work, and policy for impact. Kiros holds a master's degree in ecological agriculture and a PhD in production ecology and resource conservation from Wageningen University in the Netherlands. After Kiros, Ryan Ramage will take us on a scale up of that to on-site production services using an air curtain burner. Ryan Ramage started Valley Environmental in 2019 with a vision and hope to offer cleaner methods of disposal of excessive organic biomass and diseased woody vegetation, as well as invasive species. Valley Environmental is one of the first and only permitted companies in the Pacific Northwest that operates an air curtain burner, which has given another source to eliminate this debris while keeping down smoke emissions throughout our landscape. Ryan's overall goal is to offer cleaner and effective ways to eliminate many types of organic waste streams and stockpiles. So really excited to have you both here with us today, to our speakers. And I would say let's get this conversation underway. So Kiros, take it away.
Thank you, Bianca. Let me share my screen. Thank you, Bianca, and welcome everyone to this webinar series focusing on small-scale biochar production and application with examples from Africa and how we can use it in the US. I'm Kiros Hadgu, working with American Farmland Trust as a soil health and biochar scientist. The focus of our talk today will be touching on small-scale biochar production in Africa and what are the methods and the source and the feedstocks, the production methods and the applications. So we'll dive in with this. Imagine if smallholder farmer in Ethiopia or other parts of Africa can do it with limited resources, limited financial or income. You can do it here in the US if you have time, and because it doesn't cost a lot if you don't have income or investment to invest in large machineries. It can be easily done with available resources, agricultural wastes, or invasive species that you have in your area. To give you some context, in Africa, there is a lot of land degradation, climate change, soil erosion, which is affecting the lives of people, the livelihood of the people. But biochar is a great opportunity. It's tackling these problems by being used as nature-based solution without investing or importing fertilizers, chemical fertilizers from other parts of the world. So farmers are now using the local resources by turning what's available in their area and improving their soil health, improving the land, improving the land soil fertility and improving productivity. There are global, regional, and national initiatives like the Bond Challenge, pledging to restore 150 million hectares of landscapes and forests. So the biochar is one of the components, contributing towards achieving this initiative. In Ethiopia and other parts of Africa, farmers are using this low-cost, farmer-friendly approach to convert waste to opportunity, like maize cobs or other leftovers, invasive species. So without competing with other food sources or without cutting trees, degrading the environment, it's possible that farmers now are converting these wastes to opportunities from maize cobs, peanut shells, and invasive species. We'll dive in later on. And they are using different traditional kilns and gasifiers like peat or oil drum to reduce the smoke, or gasifiers to also use this. It has triple winds, a source of energy, to also important for health in when cooking, and also as source of biochar at the end. Well, invasive species are now a problem in Ethiopia, in other parts of Africa, also in the US. Ryan will talk about it about the invasive species in the US, but to give you some example from Ethiopia, farmers are converting this Prosopis gyriflora, by making it to biochar out of it and using it as amendment to improve the soil, organic matter, improve water holding capacity, and to deter the invasiveness of the Prosopis gyriflora. So it's a solution in biochar is a solution in this aspect. Another study in Ethiopia indicates biochar, when used with compost, improves crop yield, like teff, Iragrotis teff, which is one of the staple crops in Ethiopia. It's also gluten-free. It improves by 315% as compared to use of inorganic fertilizer alone, because using inorganic fertilizer in non-responsive soils, highly degraded soils, doesn't give you much. So biochar is very important when it is used with compost and other amendments. Another study in Kenya, peat kiln biochar improves 20 to 30% of maize. It improves the maize, and also improves the soil acidity by improving pH from 5 to 6.5. This was, consistent, in different feedstocks and also sites. So this can be done also in the US. Whenever you have leftovers or agricultural wastes like peanut shell, maize tuber, or coffee husks, rice husks, this can be done in the US as well. So what are the opportunities in the US as compared to Africa? Okay, there is limited feedstock in Africa, limited resource, finance, but they have labor. This can be done also in the US, having feedstock sources, low-cost setups, and extension services, agricultural services, and also potential to contribute to additional income. So this can easily be done if you have time and land to apply this biochar. So we often get questions from farmers in the US. So what kind of feedstocks should we use for making biochar? There are like wood wastes, like prunings, hardwood branches, or agricultural wastes, crop residues, or dry manure, cow manure, or poultry manure. So you have a lot of resources, which are most of them are like wastes. So how do we really convert these wastes to opportunities, to something important as biochar? Another question is, how do you prepare feedstocks? So we have to dry it at least to make the moisture less than 25%, and also to prepare it in smaller pieces. Like if you put wood with big diameter, then it takes time to burn and less efficient in converting it to biochar. And if there are some plastics or chemicals, it has to be cleaned before converting it to biochar. Well, before diving into the different methods of biochar, like peat kiln, drum kiln, or flame clean cap kilns, let's see the concept. Here, air, flows, and then on top it burns the smoke before it gets down to the biochar down. So it's more efficient, by protecting or limiting the oxygen going down to the biochar. So this is one of the efficient ways of it's now documented in fact sheet with the biochar online site. We are working together on fact sheet. So this is an important concept that we need to understand. When preparing peat kilns, you can, depending on the biochar source or on your aim, you can dig 3 to 5 feet deep or 6 to 9 feet width. So it's very easy if you have time and labor, and this can be done very easily. You can convert, crop residue or wood by burning it and at low oxygen, and also quenching it with water. Because if you keep it burning, then it will be turned to ash. So when you see the top flame turning to red, then you have to quench it with water. There is also this drum kiln method. We can easily make it from oil drum by putting chimney on top. So it's also relatively cheaper, $30 to $200. So you can fill feedstock and seal it with the chimney on top, and burn it, leave it for burning for 1 to 2 hours, and then later on quench it with water to make it more efficient in producing in making the biochar. The other flame cap clean method is simple. It's also portable and affordable tool. Relatively, this is about $2,000, but yeah, but it's very efficient in terms of making biochar. Similarly, the process is you can add biochar, wood, or prunings, and keep adding. When you see the top burning, it stops. Finish burning and like turning to ash, and then when you finish, you quench it and then unload and dry it, and later on mix it with compost or manure. So this method, the ring of the fire biochar kiln, can convert wood waste to biochar with 15 to 20% efficiency, and it can be easily loaded, with machineries. Another question we get from farmers is, how do we really match feedstocks to methods? This is not always, what mostly I recommend is if you have crop residue like stover, straw, or maize stover, it would be advisable to use pits or drum kilns. For wood, it's more efficient to use the clean flame cap, like the ring of the fires, to make it more efficient. And for manure, also drum kiln. But this is not always, it's not a blank recommendation, but this is what we mostly recommend. How do we apply biochar is another question that we get from farmers. So do we apply it straightforward from, after making the biochar? No, because if we apply it directly, it will, take all the available nutrients from the soil, then it will have negative effects. So to avoid that, we have to, to mix the biochar with compost or manure and leave it for 1 or 2 weeks so that it's charged with nutrients before it's applied to the soil. The dry biochar is also is not recommended because it has some health issues. So either you moist it with water, or discharge it with manure and compost, or with protective equipment. Recently, we had questions from our colleagues in California. They received dry biochar, and then they had this issue of dust affecting their health. So the other question is, how much should I apply? It depends also on the purpose. If you have small garden, or if you have big plot. So, but usually it's 0.5 to 5 tons per acre. This is what we recommend. But again, the purpose and the end goal determines this. So the method, you can spread it, or you can apply, use manually, or till it 4 to 6 inch. There is also injection method recently being introduced. So there are different ways of applying. Well, in timing, it would be good if you can apply it before plantation in spring or fall, but it can also be overdressed later on. So what is good quality biochar is another type of question that we receive from farmers. If you can send it to a lab, Kristin Trippe has a lab which can, she's helping and with her colleagues in testing the quality of the biochar. But if you can, test it, feel it by your own, good biochar is dark, brittle, and gritty. So it doesn't have any odor, no smell at all. You can even test it. Yeah. So this is what you can do by your own. For wood biochar, the carbon is greater than 70%. So if you aim to improve carbon in your farm or in your soil, so you can use wood biochar. The pH is 6 to 8, and for crop residue, the carbon is greater than 50%. So if you have, so it depends on the option. If you'd like to improve the acidity, so you would go to more ashy biochars. So what are the ongoing and future works that we are doing at AFT together with ARS and USBI and other partners? We are working on improving quality of biochar, and then how do we select the best biochar quality and the feedstock? What are the right feedstocks for the right methods to be applied at the right time for the right soil? So this is work going on with Kristin Trippe and USBI and with other partners. So we are working on the rates and application approach in our trials, biochar trials, led by AFT, ARS, and USBI. And there is also a decision support tool, which can, Kristin was mentioning earlier about this global, the Atlas, Biochar Atlas. This is very important tool that, can help us to decide which biochar to apply where, when, and at what rate. The other ongoing work we're working on is market access. How do we really improve the market access for biochar? How do we, make it more appropriate for home and farm heating and energy use, besides the soil improvement or for soil health? How do we really, use this untapped opportunity of biochar for heating and energy use at home or at greenhouse? We need more. We have some ongoing work, but we need more to work more on training, awareness, and connecting biochar producers to users on the value chain on these aspects. Yeah, thank you very much for your attention. I would like to invite you more to join our AFT's mailing list, to work together and to interact more in the future. Thank you.
And next we have Ryan. I see your slides up, so go ahead, and thank you, Kiros.
Awesome. Thank you for having me. I'm excited to be a part of this and kind of explain what we do in our journey and how we've got into this biochar world. We could go to the next slide, please. So I'm Ryan Ramage. I'm out of Canby, Oregon. Like we stated earlier, I started my company in 2019, trying to offer some cleaner methods for our biomass issues out here in the Pacific Northwest, seeing the issues with a lot of diseased materials, invasive species, and just overall excessive biomass. So what we do out here is we operate an air curtain burner. The model that we run is a burn boss. There are also other models out there as well for different size projects. But yeah, so we've been operating our Burn Boss out here for the last 4 years, and we are one of the only companies in the Pacific Northwest permitted with this type of technology. And so yeah, I'd like to show you some of our different projects and equipment and go into the biochar more. Slide, please. So this is our setup. This is our air curtain burner, and then this is also our truck that we use that hauls our water tender with us. And starting out, we just kept this water around, for backup. But then as we discovered this biochar world, we use this now to quench our end product and create the biochar. Slide, please. So some of the great projects that we've been involved with and why we started our company is invasive species. So this project that we are working on here, this is all emerald ash borer material. So the emerald ash borer has been spreading across the US and is now getting into Oregon, and Washington County has been hit the most out here. And this is where we're doing this project here. So working on these types of projects with Clean Water Services and ODF, they've really liked seeing the outcome, because with the spread of these invasive species, and then also compared to common practices, you can't really argue that these things have survived our air curtain burner. To where chipping and burying product, you can question, hey, did we really get rid of this bug? So, and then also too, these types of projects are not far out of urban areas. So we're not smoking these areas out by burning. And I'll explain as we show some more pictures of how our machine operates. Next slide, please. So this is a project that we did up in Hood River, Oregon. This is all orchard debris. We started going up in Hood River because they were having a lot of smoke sensitive issues. And some of these projects really opened my eyes to, the benefits of biochar, what we can do. And like with this project here, we were able to leave this farm leftover product that can go back on their orchards. But a big part of this whole thing too is, yeah, we didn't smoke this valley out. They don't have to move this material anymore. And we were able to, just eliminate this debris very quickly in effective form. Get another slide, please. This is back up at Hood River as well. This kind of gives a little bit better view of the valleys that get smoked out. As you can see off in the distance, and we'll show some other slides too showing this, they're getting all these areas smoked out, burning the exact same debris that we're burning out there. So we had multiple jobs in this area, and this was up at another orchard extension through OSU and their conservation, and they really liked having the end product. Again, they did use the biochar to go back and do some soil sampling and put it on some new trees and all that. If I get the next slide. This is one of my favorite pictures. So when people ask, why not just open pile burn? Why use an air curtain burner? This shows a lot right here. Our machine's operating, and right here in front of us is the manifold that is pumping air over the material in the burner. Show you a little bit better picture here in a second. And we are in full function. So we are operating, and we're videoing through the output of our machine of what we're countering off in the distance, which is open pile burning. I watched that pile get ignited probably 6 or 7 times. So we can only imagine how much fuel it started, where, to get going, diesel, all that, to where I generally use 1 gallon to 2 gallons of fuel to ignite. And then we just use the blower and the heat in the box to get going. So it really shows the efficiency on it. And again, not smoking everybody out of there. That really, people had no idea we were even there working because of the emissions that, we're really not putting out. And apologize on our video. Was going to show more inside the box, but we'll get there. Next slide, please. So this is again showing full operation, what it looks like inside the box. To the left is again the manifold that is pumping air and circulating air over there, which is keeping the emissions trapped inside. about once we get up to operating temperature, about the only time you get smoke is when you load it, and it'll poof up, and then the curtain will just seal it right back up. This was a forestry cleanup project, kind of a smaller scale forestry one. The neat thing on this is, again, not far out of town. On this project, there was a neighboring property burning open slash, smoking the whole valley out. We're sitting in there. Again, nobody had any clue we were there. And then we left this biochar for our customer who has a small vineyard, and they utilized the biochar and put it back on their grapes. So it was a good story on that all around. Next slide, please. This was supposed to be a video. This is more emerald ash borer debris. Let's come here. So this was the same project as I showed earlier. And yeah, just getting rid of those nasty little bugs in that material. And we left quite a bit of biochar for the customer to play around with on this project. Next slide, please. It's just showing, this is on the other orchard project I was showing you. So showing you kind of inside what it looks like. Another view of the manifold off to the left. You can see all the holes there, pumping the air in there. Next slide, please. And so as we, when I started this business, it was mostly for biomass utilization, just cleaner methods, different practices, trying to make some changes in our environment. And, it's kind of stumbled into this biochar world. Even though my main focus is the biomass, I do have a lot of customers that do want this char, and it's cool that we can make it. So after burning all day, this is about what we leave. How the air burner works is the black box hydraulically lifts up, and we just drive off of the pile and then come back around with a water tender, and we quench all that char. So after burning, the machine will do 5 to 10 cubic yards an hour, about a ton an hour. And so we can burn all day, and we leave 2 to 3 yards of biochar. So not a whole lot, but again, our main focus and what the machine is for mostly biomass utilization. Next slide, please. And here's another closer look. So after learning more about the biochar world and stuff, it is pretty cool to leave our customers these nice big black strips of charcoal. A lot of other benefits too is, with burning it this way, is we're not scorching the ground. Obviously not smoking these areas out. If their customer wants to play with it, great, and they do quite a bit. Worst case, this material can just get spread out. Like, we've just taken the carbon, compared to other practices, we're basically taking the carbon out of the air and, putting it back in the soil. There's projects and customers I work for that will do, an annual cleanup project. And I've gone back, and you can hardly tell that I was even there. You have to really scrape some grass to see the biochar, because they have spread it out through the grass or whatever. And so it's good. We're not leaving a very big impact to the ground. Next slide, please. Again, another big strip there that we were able to leave. And next slide, please. This is what we left out of all that emerald ash borer material. So with some of these emerald ash borer projects too, what we are hoping to see, and I know because Clean Water Services out here has been very proactive on changing ways in their area. So like some of this biochar, I believe, is even going in some of the new street trees that are replacing these ash borer or these ash trees that are getting ripped out. So it's a pretty neat story to be a part of, that we're taking, an issue, turning into a product that could also help out with another issue, which is sidewalk trees, issues. So if we could get deeper root growth with the biochar going in these street trees off these diseases, like it's just a great story all around. Next slide, please. This is a project that we worked on at a golf course. They had a lot of storm waste from the ice storms that we've had in over the last few years. And they used to be able to open pile burn, but then they got put into a smoke sensitive area and they weren't able to do that. So they had us come in. This was quite a mountain of debris, and they were really happy, and the golfers were really happy because we were able to eliminate all this material, and we had golfers walking right by. We didn't smoke everything out. We offered a good solution, and it's kind of opened their eyes too to seeing, hey, what's the benefits of this black stuff that's out here? And hopefully we can get more of these golf courses to look at biochar as more of a larger scale soil amendment to get out there, which I know has been done in other parts of the country. So this has been a good thing to kind of open that door. Again, just offer some more solutions to this industry. Next slide, please. And then, yeah, back to the Hood River smoke sensitive. Just off in the distance, you can see the difference that the air curtain burner technology does. And then next slide, please. So one issue with our industry out here has been permitting, and permitting has been very expensive, been a lot of regulations, but also being one of the first ones out here, I've been able to work with DEQ out here, who's our air quality, work with other agencies like Oregon Department of Forestry, Forest Service, Clean Water Services. And so because they see the benefits in this technology, we're working on some rule changes to make it so it's not so expensive. So DEQ did a test out here, and we were part of it. So they had this hood custom built, and then you can see off to the right the long tube and then a blower on the end. So the tube has sensors all through it, and there was an air monitoring company that did the work, and we burned for a few days, and it was great because we got to burn another issue, more emerald ash borer material, and we got really good results. And we are now currently seeing some rule changes out here, so it will make it a lot less expensive for permitting and keep growing this industry out here. If I could get next slide, please. So yeah, that just kind of sums up what we do out here, how we've gotten into the biochar world. There are different types of air curtain burners out there. There's a couple sizes bigger than us for different size projects. There's one also called decarbonator, which is great for some of the larger forestry products or projects like Big Slash. That one does produce biochar as it burns. But yeah, it's so there are some different types of equipment out there, and hopefully we will be growing and getting larger size so we can do larger projects. So so I'm looking forward to more questions if anybody has any after this, and I appreciate the opportunity for being here.
Great, thank you, Ryan. Myles, I think we're ready for the Q&A session if you want to start asking some of the questions that we have.
Yeah, great. I think since Ryan, you just finished up, I think maybe we'll just pile onto your presentation now and go with a lot of the questions that are focused on your work, and then we'll hop back over to Kiros after that. Some of the questions I have are related to sort of the current status. So one of the questions I have is what's the current status for waste disposal in the areas where you commonly operate? You were showing a lot of work related to diseased trees from the emerald ash borer and also orchard prunings. So I guess my question is what's kind of the common disposal practice right now in a lot of these areas for that material?
Well, they claimed on the disease stuff that it supposedly gets quarantined or buried. When I was starting hearing that before I started my business, I kind of was questioning that, and that's why I looked into other alternative ways. We out here, we also have a lot of landscape wood waste places that a lot of this material will get dumped off and composted. But a lot of these sites are getting to be there's so much of it that they're getting kind of busting at the seams. Orchard waste and agriculture waste in general is just getting open pile burn quite a bit. And so, yeah, those are kind of the main things there. Chipping is another one too. But with the chipping, unless you're using it on site, a lot of times you have trucking costs that need to be tacked on that, and you have a material that you just have to move quite a bit.
Yeah. So clearly, air quality impact, and obviously, I think what you showed and the data we've seen for these units is that they're sort of dramatically reduce air pollution from disposed material. Yeah. Another question I have is like, what do you see in terms of your biochar yield? Like when you produce this stuff, do you have a sense of what kind of yield you get off of each kind of ton of feedstock that you put in?
It kind of depends, but I just did a project that should give some good perspective. Like we just did a bunch of juniper slab debris, and we weighed everything. It was 7,700 pounds of juniper material that we did, and we ended up leaving. I didn't get the final weight on the biochar, but because they were weighing it as I left, but we got about 3 yards out of it.
Okay. Yep, and that's wet weight. Okay, great. You mentioned permitting. So question I have is, what's the current status? So these projects are all in Oregon. So questions are, what's the current permitting requirement for your operations? And also kind of how do those compare to open pile burning permits, given that that's kind of the typical alternate pathway for this material?
So one of the big hiccups is, the air curtain burners are identified as an incinerator, which are technically not, but because they are an incinerator, it puts them into a Title V class, so a little bit more extreme. So the permitting fees have been very expensive. And within this timeline too, they've also had some very drastic increases, which has, kind of raised some concern of, hey, this is really hurting our industry because we're trying to bring a cleaner method to here compared to open pile burning. So there's been some really good proactive action going on. DEQ is working right now. Well, first of all, EPA did a rule change that trying to reclassify the equipment, and then DEQ is currently working on that. And then we also just had a House bill go through that's kind of pushing that as well. And it just got signed by the governor 2 weeks ago. And so that should help expedite the whole classification rule changing. And that will change the permitting fees like pennies on the dollar and help out this industry quite a bit.
Yeah. Okay, great. Next question is related to feedstock size management. So I saw that, it looked like a mixture of sizes that go into this unit. Is there anything you do on the front end to manage the feedstock size, or would you need to do anything if there were different types of feedstock? Like, is there any way that you manage feedstock size?
Out on the job, most of the stuff's already down to size that I need. I mean, there are certain size jobs that I wouldn't do just on diameter, or like some of the larger forestry big slash piles. Like there's different size machines, so I would recommend going with a larger machine for that type of stuff. Diameter wise, I try to stay about 8 inches or below so we can be efficient, so we're not blocking the airflow and slowing down production with large stuff that we're trying to go through.
Okay, great. So, the approach that you've been talking about is really biochar as a service, which, clearly makes sense in the context of relatively small properties. I guess one question I have is whether there's a scenario you envision where like a really large farm could ever get to the scale where it would make sense to operate their own, or is it just sort of too variable in terms of timing and things like that to really make sense? So maybe you could just kind of speak to that of whether, where sort of the decision-making process might go around whether or not a farm would own their own system, or just sort of hire out, a company like yours to sort of provide that kind of service.
A lot of that just depends on the size of the farm. If you're looking for a smaller farm, hobby type farm, our machines would be fine. If you're looking at a larger scale, that's where I'd recommend looking out and just buying it, commercially at a larger bulk. And that's where you're going to save money. You're going to get materials broken down and finer, and will spread a lot easier on the larger farm applications.
And do you imagine like the learning curve is like, I'm sure you've gone through the learning curve, clearly,
Yeah.
of how to operate these units. So, I guess that would be a question I would have is what does that look like? And does that become feasible on a large farm, or do you have to have somebody who really knows what they're doing to operate these right?
Yeah, and that's the thing is, yes, there is a learning curve on there, and that's that question comes up quite a bit. People, oh, just go buy it. A lot of agencies buy them, but it's not just a push button and go. You do have to know what you're doing. And so, what's happening in other states that I've heard is there's a lot of these machines sitting because they'll get an employee trained to do it, and then that person either just leaves for some reason, and then they don't have anybody that knows how to really properly operate it. And so yeah, training and keeping on it is a very key thing. And yes, I've gone through quite a few learning curves on it. And so yeah, there's an art to it.
We want that video, Ryan. All right, last question I have is related to carbon removal credits. So there's clearly a lot of interest in the biochar industry around, carbon payments for biochar production. And I'm curious if you have investigated those or heard of anyone using this size system to sort of generate those credits.
No, and I've been approached about it, and just from what I know, like I'm learning a little bit on the stuff. I just don't feel like I'm large enough scale to make it worthwhile. And some of the people I've talked to, I've kind of thrown that out there, and then once they figure out like how much we really produce, they kind of agree on it. So yeah, I think they're more focused on the lot larger scale stuff for the carbon credits. So.
Yeah, I've heard something similar around these units that you'd have to really probably group up a number of these, burn boss or char boss units and really kind of combine those or aggregate those into a single carbon credit product. You need to have sort of a fleet of them.
Yeah.
Well, great. Really appreciate your time, Ryan. That's all the questions that I saw for you, unless I'm missing one.
Yeah, we have
oh, wait,
some in
no.
the Q&A.
Yes. Okay, great. This is a good question. So, and you spoke to this a little bit, is how did you build out this business, and what was sort of the risk at the beginning around purchasing this unit? And is that a leap of faith, or did you kind of see the market already there?
Oh, good question. I saw the need for it. And where I was at just in my professional career and this and that was ready for a shift and a change. I knew the hurdles that were coming up. There have been more big, other things that have popped up too. And I know I kind of joke like maybe it's a midlife crisis, jump in and go for it and stuff. But I saw the opportunity for a change. I was seeing the current practices. I know that we're working on environmental stuff agenda as a whole. And yeah, I don't know, just jumped into this stuff and went for it. So
Yeah, great. And then final question is related to insurance. So, you talked about permitting, but the question we received was, how did you get insurance, and how did you get an insurance agent to even understand what you're trying to do? And then I guess, how did they then understand how to price risk on this?
great question, big hurdle. So the story with my insurance is I did a little research, talked to some other people in other states, and was basically, yeah, no problem, no problem. So here I have this nice expensive machine showing up, and I probably should have done a little bit more on my end. And then come to find out, when my insurance reached out to this other insurance, they weren't insuring them properly. And so that was a big like, oh crap, what did I get myself into? And then with the wildfire stuff going on and all this stuff and the way the insurances are being very, very picky, yeah, I was kind of sweating bullets on some stuff because I was getting denied. And with insurance, if you start shopping too much, you start getting flagged and all that. Luckily, I found a good company that does more forest management stuff, and they understood. They weren't scared when they saw the word fire or this and that. And so my premium was not as bad as I thought, and it's been working out good so far. So
Yeah, that makes a lot of sense that it would be a forestry related insurance provider.
Yeah.
Yeah.
But we
All
also
right.
had a
Well,
hurdle too
yeah.
that, this one company, we'll insure you for government jobs, but not private jobs. So then we had to find another insurance company that said, we'll insure you for private jobs, but not government jobs. So it didn't make sense. So here we are, years later, we finally have a company that's insuring us for both. And so, yeah, so insurance, that's a great question. Anybody looking in this industry, definitely dig into insurance before you start doing anything. So.
Yeah. Yeah. And, maybe you've sort of paved the way for some follow-up, at least regionally.
Mm-hmm.
Yep. Well, great, Ryan. Thank you for your time. Really appreciate it. And, very inspiring work you're doing.
All right. Yeah, I appreciate the opportunity of being here. Thank you.
Yeah. All right, Kiros, I have some questions for you as well. So let me wait till I see you on the screen here. Yeah, there you are. All right, good.
Yeah.
Excellent.
Thank you.
All right, so first question is, in terms of like if you're trying to make some small scale biochar production and then spread it by hand, it's sort of in your garden or your small plot of land, small farm. What are the practices that you would use to maximize the biochar production in that sort of small scale on-site approach?
Yeah. Thank you. It depends on on the size of feedstock or the production method you have, but usually you have to prepare the feedstock and dry it before putting it to, for example, to peat or other kilns. Don't use wet or green biomass because it reduces the efficiency of the yield and the efficiency of the biochar. And you have also to control the oxygen. Start with small, and adding little by little by controlling the oxygen, limiting the oxygen, and then once you see clear smoke, when it's finished, then you can quench it and later on dry it and crush it. And before applying to the field, you have to make sure you have to charge it with nutrients from compost or biochar by letting it absorb the nutrients for 1 or 2 weeks. This is the kind of question we get from farmers. Okay, I applied biochar, but it's not giving me yield. It's the other way around. It's negatively affecting the crop. So you have to make sure that it has to be fully charged with nutrients by mixing it with compost or with manure or with other nutrients. So this is simply that you can apply. Yeah, thank you.
Yeah, great. And what's the time look like? Like how long does it take to, you're starting with piles of branches or other sort of residue, and what sort of the timeline look like in terms of like day? Like is this like a 2-hour event or like a full day event?
In preparing the feedstock, if you have it ready in your garden, it may take you 1 hour or 2 hours. But if you have to collect it from forest or from other places, it might take you 1 to 2 days, to collect it and drying it, making it prepared. So just give it like 1 to 2 days, collecting, drying, and making it ready. And burning takes. This also still depends on the quality of the feedstock. If it's dry, ready, it might take 2 hours. It might take 2 to 6 hours. If it's woody, hardwoods, takes time to burn. If it's just branch, it takes like 1 to 2 hours. So give like 2 to 6 hours. And to just cooling it, processing it, maybe 1 day, just quenching, drying and crushing. It might take like a day, and to turn it to charge it, maybe 1 week or 2 weeks with compost and nutrients. So give like 2 weeks in average for this whole process. But
Okay.
it's not full time. You know, you don't have to invest full time in this. You can do it, you know, after work or when you're resting or when you have finished other things. So it's not time consuming.
Yeah. Great. So just in your prior answer, you talked about sort of, you know, mixing raw biochar with things like compost or manure, and particularly when you're going to use that on a crop that's going to be planted soon. So question is, you know, in a lot of contexts, you're not going to have that available. Not everybody has compost easily accessible or manure. So I guess the question would be, you know, in cases where you don't have that, what are some practices that can be compatible with more of a raw biochar? Like is that something you can do in the fall as long as you're not planting right away, right? To sort of age the biochar. Like what are some approaches when you don't have the availability of compost or other nutrients, you know, to use raw biochar while still being a benefit?
Yes, if you don't have compost, you can use you know, even we can use cover crops, especially you know, nutrient rich cover crops. If the preferred way is to just to charge it, but if it's not you know, available, you can use you know, like other, you know, products which are rich in nutrients. You can also overdress it. You know, if you miss the season, there is an opportunity to overdress it, to top dress the biochar. But
Mm-hmm.
the usual thing is to use compost, manure, or other you know, nutrient-rich materials. So this is yeah. Instead of using it, you know, raw, dry, and without anything, then because it you know, takes all the nutrients, then it has negative effect on the crops and on the soils. So this is what we need to make sure. Farmers, before using it, they have to charge it with nutrient-rich, you know, organic materials like compost or manure or other products. Thank you.
Yeah. A couple more questions around sort of energy utilization, and this probably, yeah. So the question is, the context you're talking about is relatively small scale. So the energy is, you know, used to clearly drive the process. But I guess the question I have is whether or not there are examples in the global south or elsewhere where you're seeing smaller scale producers use that heat or the syngas that's produced during biochar production, and if so, like how they're using that, you know, in sort of these smaller scale systems.
Yes, there are some, you know, ongoing work in Africa with the gasifiers, you know, while using energy for cooking, and also reducing, you know, minimizing the risk of smoke. You know, people are now producing biochar, so they use cookstoves, improved cookstoves, with while producing biochar. So cookstove and also biogas digesters are now you know, getting popular in Africa and other parts of you know, the global south. But here in the US, there is an opportunity to use, you know, as for greenhouse heating, while, you know, making biochar, and also for water heating, for outdoor boilers, and also, you know, for cooking and processing, food processing purposes. So there is a great opportunity in the US to utilize, besides the improving soil health, there is a great opportunity to use the energy, the heat, and the gas for other purposes. So it has, you know, many benefits, not only in agriculture but also in other energy and, you know, so many things.
Yeah, you know, one of the interesting ones is sort of greenhouses and whether or not you can connect biochar into greenhouse production. You know, even things like the heat content clearly has some value, though I guess it's seasonal in a lot of cases, but a really important way that biochar can be used.
Yeah.
Yeah, really appreciate it, Kiros. I don't see any other questions that I've received, but maybe we could hold a little bit, or Aisha, maybe if you haven't seen any more.
I've not seen it anymore.
I see one from Josh. Huh?
Oh.
On yeah, he asked about. Did I miss a question?
He asked, is there
About
technology out there that can burn ag products in the
technologies,
field?
biochar technologies. Sorry. Yeah, he asked, is there technology out there that can burn agricultural products in the field without having to lift or harvest them? Maybe Myles or Ryan.
Well, there are a few technologies that I've seen. There are a few companies developing technologies. The one that I'm most aware of is a company called Applied Carbon. They're based, I think, in Houston. They have a system that essentially is a mobile biochar unit that actually moves around a field while harvesting. They're primarily focused on corn stover at this point, but pulls corn stover up into the system and turns it into biochar while driving around, while sort of being pulled behind a tractor. And then it actually discharges that biochar on the move. So it's essentially mobile through a field. And Takachar has a system they're designing that's similar. So both those companies would be sort of pulled behind a tractor, would be combined with something like a combine or another device, another piece of equipment that grabs the stover and then sends it into the biochar system, which is pulled behind the trailer and then just discharges biochar while it moves through the field. So pretty cool technology, and really could make a lot of sense in systems where you don't already have the material in a pile. Ryan, in your case, a lot of times you're being contracted to deal with a pile that somebody has, and you're not being asked to go around and collect it. Typically, it's already in a pile, so that sort of makes it a little bit easier logistically. But some of these systems can sort of effectively move through a field in that way. So, well, great. I don't see any other questions, so really appreciate all of your time, and the AFT team really appreciate your efforts on this, and USDA. Ryan and Kiros, really appreciate your both being willing to speak as part of this webinar series. And Aisha, maybe I'll just hand it over to you for the final word.
Yeah, thank you, Myles. So yeah, thank you everybody for attending the webinar today. There were many resources that were shared in the chat. And please take the time to fill out the survey that I just shared in the chat as well. I shared it earlier in the program as well. And as Kiros mentioned at the end of his talk, please take the time to join the AFT's mailing list if you do not already receive the email from us. And when you do follow that link to join the mailing list, make sure that you click on climate info, and that way you'll get all the biochar info that we send out. So thank you again, and we will see you next time.
Thank you.
All right, thank you very much.